Glitch. Every speedrun trick starts here. A glitch is any unintended behavior inside a game that a runner uses to save time. It was never placed by the developers. It appears when the engine misreads a condition, when two objects interact in a way nobody planned, or when the game simply skips a check it was supposed to make. Some glitches are visual and useless. Others break the entire structure of a game. Every other trick on this list is, in some form, a glitch with a name. Sequence break. Games are built with a specific order in mind. Complete this area, unlock that gate, then move forward. A sequence break skips that order entirely. Runners find a path, a gap in the geometry, a forgotten trigger, or a movement exploit that lets them reach a later part of the game before the developers expected anyone to be there. In Metroid and early Zelda games, runners discovered they could reach the final boss with almost none of the required items collected. Out of bounds. Every game world has edges. The developers build a playable area and place invisible walls around it. Out of bounds happens when a runner escapes that area entirely. A specific angle, a precise speed, or a collision error pushes the character through the boundary and into the empty space behind the map. From that empty space, a runner can sometimes walk in a straight line directly to a level exit, bypassing every obstacle placed inside the intended path. Clipping. Clipping means passing through solid geometry that should block movement. It happens when a character moves fast enough that the game's collision detection fails between two frames. The wall exists, but the engine never registers contact. Thin surfaces and sharp corners are the most common weak points. In most 3D games, at least one wall somewhere in the world can be clipped through with the right angle and enough speed. Runners find these walls and turn them into consistent shortcuts. Wrong warp. Games use internal identifiers to track where a player should be sent when crossing a boundary or loading a new area. A wrong warp corrupts that identifier. The game reads the wrong destination and sends the player somewhere unintended, sometimes to a completely different world. The most documented example is Super Mario Bros., where runners trigger a warp that skips directly to World 8, the final world, without visiting most of the game. Death warp. Dying on purpose sounds counterproductive. In many situations, it is the fastest option. When a respawn point sits closer to the runner's destination than any walkable path, intentional death saves time. The trade is losing a life in exchange for a repositioned character. The respawn animation plays, and the runner appears exactly where they need to be. In games where the respawn is faster than backtracking, dying is the correct decision. Save warp. Save warping uses the game's own save system against itself. When a save file loads, the game places the character at the recorded position. If that position is more useful than the current one, reloading is faster than traveling. Runners sometimes manipulate where the save registers before loading it, turning the save file into a controlled teleportation tool. Arbitrary Code Execution. This is the deepest trick in speedrunning. Arbitrary code execution allows a runner to write and run foreign instructions inside a game while it is playing. By corrupting specific memory values through precise in-game inputs, item arrangements, or position data that overflows into executable memory, the runner injects a small custom program into the game. That program typically skips directly to the credits. ACE has been used in Super Mario Bros., Pokemon, and other classic titles to finish games in under a minute. Pause buffering. Some inputs must happen within a single frame, around 16 milliseconds. No human can consistently react that fast in real time. Pause buffering creates a controlled way to execute those inputs. The runner pauses, holds the required input, and unpauses. Because certain games process one frame of logic at the moment of unpausing, the input registers on exactly the right frame. It slows the runner's real time without slowing the game. Frame-perfect input. Frame-perfect tricks require an input on one specific frame. One frame too early or one frame too late, and nothing happens. These are the hardest techniques to execute consistently. They separate casual runners from competitive ones. Muscle memory built through thousands of practice attempts is the only reliable way to hit them without mechanical assistance.